guys, welcome back to my channel. Today I'm going to be talking about partial derivatives. Partial derivatives. So in partial derivatives, as hinted by the name partial, we are just trying to find the derivative partly. So not fully, but partly, and in terms of one of the variables. So let's say if we have variables x and y in, let's say, an expression, we would just find the derivative with respect to one of the variables, say just for x or just for y. So that is what we find for partial derivatives. So say we have an example that looks something like this. And we are trying to find the partial derivative for this with respect to x. So we are trying to find fx right here, and we are just going to treat x as the variables, and y's are going to be treated as constants, like numbers, like say the number 5 or something like that. So these y's are just going to be treated as numbers. So let's rewrite this first. That's what I like to do. Let's rewrite this. So let's rewrite this. So here we have 3x squared, right? Just normal. Now here with negative 2x times y, we know y is just going to be treated as a constant. So why not just put it with the 2 together, right? Put these two together, and then the x by itself, just like this. And when you put the x by itself, it shows that we are differentiating it with respect to x, right? And this is treated as the constant. Now here we have plus 5y to the exponent of 3. These two combined together as a constant times x to the exponent of 4. Because these two are constants, we're doing it with respect to x, so x has to be separated. So here we have negative 11x, so we're going to copy that. We'll have to, there's no y with it, so we're not going to rewrite that part. Then plus y here, and then minus 3. Now if we were to find fx, we just look at the variables for x. So here we bring down the 2, in this case multiply it with the 3 as usual using the power rule. So 2 times 3 is going to be 6, and then here it's x, just x to the exponent of 1 because we subtract 1 from 2, so it's just going to be x like that. And then now here's the new part. So negative 2y, well, y is treated as constant, so this whole thing is like a constant, right? And then this x, well, if we have, let's say, a constant times x, let's say this constant was equal to, let's say, 8, okay? So let's say it's equal to 8x, right? This whole thing here is 8, and then this x here is x, right? If it's 8x, well, if we were to differentiate this as usual, it's just going to become 8. So it's like we just get this 2y right here. And we don't need to write the x if we differentiate it. So it's just going to be 2y like this. Because if we treated this as a constant, then we would just get the constant from that if we were to differentiate it as usual. Now here, it's the same concept, very similar. So 5y cubed is our constant, and here it's x to the exponent of 4. Well, the constant's not going to be affected. I'm just going to leave it like this. And then x to the exponent of 4. If we were to use the power rule, we would get 4x cubed because we would bring this 4 down, and then we would subtract 1 from 4, and if we subtract 1 from 4, we get 3. And so that's what we get, and the constant remains unaffected. Y is a constant, remember that. Now, negative 11x, we differentiate this as usual, so negative 11x, if we were to differentiate this, it would just be negative 11, because we have a constant right here, and then it's just x. So we just do that. And then y, well, y, we treat it as a constant, so it's going to be, well, a constant. And if we differentiate a constant, then that means we basically get 0. And as for negative 3, it's a constant. We treat it as usual. Normally, for constants, it's still going to be 0. Now, all we have to do is simplify this. So we're going to get 6x minus 2y plus, well, 5 times 4 is going to be 20, and then we write the x first, so write x cubed, and we write y cubed like that. Then minus 11, we copy that. And these zeros, we do not write. So there it is. We differentiate this function partially with respect to x. Now, with respect to y, it's a very similar concept, and we treat the y as the variable and the x as the constant. So in this case, we have 3x squared, right? And negative 2xy. Well, this is going to be a constant, okay? 3x squared is going to become, it's basically a constant. So if it is a constant, then the derivative of that is just going to be 0. Derivative of a constant is going to be 0. Now here, it's negative 2x times y. So it's like this part is our constant because x is our constant and y is not a constant, it's our variable. So we're going to differentiate this. So if we have negative 2x times y, normally if we have something like this, like a constant, let's say this 2x is equal to 7, right? Like let's say a constant 7 times y, the derivative of that is just going to be the constant, it's just going to be 7. So the 7 is 2x in this case, right? So it's kind of like 2x is what's going to result. Well, negative 2x is the negative sign here. So we're going to write negative 2x. And the y, well, that's our variable. So we're not going to do anything with it because normally you will just get the constant when you differentiate this. Now for this part, 5x to the exponent of 4 here, right? X is our constant as well. So this whole thing is a constant and the y is a variable. So the constant remains unaffected. So we're going to write our constant just like this. Like that. And then we have y cubed. So to differentiate that, using the power rule, we bring down the 3. It's just going to be 3y squared, right? Because if we were to differentiate just y cubed, we bring down the 3 here. 3 is going to be multiplied with this constant, and then we subtract 1 from the 3. So that's how we get this exponent of 2. Now, negative 11x. Well, x is a constant, so this whole thing is going to be treated as a constant. So when this whole thing is treated as a constant, it's just going to be 0. And then as for this y here, the y is a variable. So if we were to differentiate y, well, it's multiplied by 1, right, at the front. So as usual, this is just going to be 1, right? If you're to differentiate this as usual, it's going to be 1. And then minus 3, well, a constant, if we were to differentiate this as usual, it's going to be 0. Just like that. So now we are going to simplify this. So if we're to simplify it, well, we're not going to write the 0, so it's going to be negative 2x plus, what's 5 times 3? It's going to be 15. 15 times x to the exponent of 4 times y squared, right? We're just reorganizing this. And then we have to add 1. Just like that. This is our partial derivative for this function with respect to y, right here. Now say we are being asked to find the partial derivative for this type of function. Now with partial differentiation, it's very similar to just differentiating things regularly because we still apply the product rule, the quotient rule, and the chain rule. These same rules still apply. So in this case, if we were to find it with respect to x, we will have to use a product rule because we see this is x here, is our variable, and here's our variable as well. But y is going to be a constant. Well, we have a variable here and a variable here. If we have a variable like this and like this, normally we will have to separate this into 2, right? And use the product rule. So in this case, we're going to differentiate e to the exponent of 3x. And differentiating that, we will get basically e to the exponent of 3x, right? And then we have to use the chain rule. So 3x, the derivative of 3x is going to just be 3. And then we have the derivative of this part. Now, after having the derivative of this part, we have to multiply by the second part. So we just copy the second part as is, and then we have to add basically the derivative of this part times this by itself. So the derivative of this part, well, we have to use a chain rule, so derivative of sine is going to be cosine. So we copy this whole thing like we normally do, right? Like if we were to use a chain rule, like as usual. And then we have to differentiate the inside part because our x is in the inside right here. So to do that, we treat this as like this y as a constant. And when y is a constant, let's say if y was equal to 7, right? Let's say y was equal to 7, this 7 times x, right? X times 7 is the same as 7 times x. And if we were to find a derivative for this, it's just going to be 7. It's basically saying that if we were to do this with respect to x, we will just have to take the constant, which is just y, right? 7 is our constant, right? I mean, for example, it could be any number, right? But we're using 7 as an example. So it's just going to be a constant that's going to result. So it's our constant, which is our y. Y is our constant, so we're going to multiply by y right here. So these are two different things, right? So cos xy times the y right here, and we got the derivative of this part. Now we're going to just multiply by e to the exponent of 3x, because from the product rule we just have to copy that. And then now we just simplify. So 3 times e to 3x, just rewriting this to make it look nicer. Then e to the exponent of 3x times y times cos xy. Just like that. So this is the partial derivative with respect to x. Now, if we were to find the partial derivative with respect to y, it's very, very simple. It's very, very similar as well. So here we have e to the exponent of 3x, right? And we have sine and xy, right? Now this y here is our variable in this case. Before it was x, right? Before it was these x's. Now it's going to be y. Now it's not going to affect this really, because this is just going to be a constant, right? E to the exponent of 3x, x is a constant, so this whole thing is going to be a constant. And if this whole thing is going to be constant, it's really unaffected. Now we only have a y here, so we just have to really use the chain rule to differentiate this part, and we just multiply by the constants. So this is our constant, right? It's a constant, and we multiply this by what we get from the derivative of this. So the derivative of sine is going to be cosine, so we're going to write cosine, and then we have to copy the inside like before because of the chain rule. And then after we do that, we have to differentiate the inside with respect to y. So y in this case is our variable, and if y is our variable, normally if we have, let's say we have something like 4y. Okay, this is kind of like our x, this is our y, right? From xy here, right? xy. So pretend our x is 4. Okay, x is a constant. It could be any number. It doesn't have to be 4. But if we were to differentiate this would become just 4. Okay, so if we were to differentiate xy, it's just going to become x. Okay, very, very similar. So we will just write x right here. So we use the chain rule, and we're done. We don't have to use any product rule because there's no y here. Okay, this is a constant, as mentioned before, so it's like a coefficient, so we just multiply it. So now we just have to simplify it. So e to the exponent of 3x times x times cos xy. So just rewrite it like this. Okay, and we are done. Okay, so this is the end of the video. Thank you for watching. If you like this video, feel free to give it a big thumbs up, and also let me know in the comments down below on your thoughts about partial derivatives and as to whether the video helped. And furthermore, if you haven't already, feel free to subscribe if you enjoy my content. Thank you so much, everyone. I hope you have a nice day. And I hope to see you next time for another math video. Bye!